Unsere nächste Slammerin, Nadeen Sabha. Ihr Fachgebiet ist die Astrophysik, ebenso an der Uni Innsbruck. Wie kann es anders sein? Und Nadeen hatte eigentlich vor, hier auf Deutsch zu präsentieren. Sie hat aber heute, und zwar mehr oder weniger während sie hier auf der Bühne steht, ist eine ganz, ganz wichtige Deadline für sie, wo sie einen Antrag hat einreichen müssen. Und der hat sie dann doch noch etwas, also es ist eh unglaublich, dass sie überhaupt auf die Bühne kommt. Sie hat es jetzt, und das verstehe ich vollkommen, nicht mehr geschafft, das Ganze noch auf Deutsch zu übersetzen und einzuüben. Deswegen wird sie es jetzt auf Englisch machen. Aber sehr verständliches Englisch wird für euch überhaupt kein Problem sein. Nadeen Sabha. How does it feel to live close to a black hole? Applaus for Nadeen!
All right. So, hello everyone. Thanks Bernhard for the nice intro. And yeah, I often get asked the question, what do I do as an astrophysicist or an astronomer? So I actually research stars that are living close to a black hole, the black hole at the center of our own galaxy. But what I want to tell you, actually, what I would be doing right now, specifically if I was not here on stage, which is actually in about 5 hours, there's a very important deadline, which a lot of astronomers are working on, and me included, which is basically to apply for observing time on the most sophisticated telescope, which is the James Webb Space Telescope. So what you can see here from this graph, which shows you the number of submissions for the proposal as a function of time, as you're getting close to the deadline, we astronomers like to work till the last minute in order to improve the proposals, and me included. But yeah, I'm here today. So. Thank you. So what is the James Webb Space Telescope? So this is the most sophisticated and the biggest telescope that was ever built and sent to space. 1 second, yeah. So this telescope, which what you can see here, actually this is a miniature model of the telescope because it is bigger. And the size of the telescope is almost as big as a football field. So of course, this telescope was sent to space. So how do you send such a telescope to space, right, on a rocket? So the genius engineers and scientists behind the telescope, they thought, okay, how about we fold the telescope, right? So what they did is they folded the telescope, they put it in a rocket, not like this, of course, and sent it to space. So, of course, it was a much more sophisticated process, and it was folded. It was launched successfully about 2 years ago, so actually on Christmas Day on 2021. And the launching process and also the unfolding that the telescope comes back to its shape was a very stressful thing to watch online, right? Because there were about more than 300 mechanisms that could have went wrong while it was unfolding, and any one of them, if it failed, it meant that the whole telescope would fail. And that's what they call the single-point failures. But luckily, this didn't happen, and the telescope is operating fantastically, and it has provided already so many nice data and images, and which I want to show you one of the first ones that actually came from the telescope is this one. So this is a very nice image of a star-forming region where you can see that the size of the telescope, and it is how sensitive it is, that it's actually so many details. You see so many stars, you see gas and dust, and you see basically all the interaction between all these components. So what is special about the James Webb Space Telescope? So besides that it is big and it is sensitive, it's observing in space, it observes in the infrared. So why do we care about the infrared? So as you can see here from this image of a firefighter exercise, is that if you're looking in the optical, or basically what our eyes can see, which is the image here on the left, is basically you cannot see anything through smoke. But however, if you switch on infrared cameras, which what you can see on the right here, you start seeing much more detail that are hidden behind the smoke. And actually, besides that you can see through the smoke and the dust, it also can tell you about the temperature of the objects that you're looking at. So all objects are emitting in infrared, and the hotter they are, the more bright they are in the infrared. And what you can see, it's already displayed here, that the oxygen tank of the firefighter is darker, and that's because it's colder than the firefighter himself. So infrared is important because you can see through the dust, and this is why I want to use the James Webb Space Telescope and use infrared, which is basically because we are in our own galaxy and we are looking through the stars, through the gas and dust that is located between us and the center of the Milky Way. And because the center is far from us, but it's also crowded and it has many stars, much gas, much dust that is there. So this is an image of the center of our own galaxy. This was taken with the Spitzer Space Telescope, so it was the predecessor to James Webb. And what you can see, it is so crowded, right? There are so many stars, so much gas and dust, and it's all seems to be concentrated toward the center of this image. And that is where basically the position of the supermassive black hole, which we call Sagittarius A star. So I don't know how many of you have seen Interstellar, and in Interstellar they showed actually a supermassive black hole, which they called Gargantua, and it was very nicely, accurately depicted there. So Sagittarius A star is a supermassive black hole also. However, it's 1,000 times less massive than Gargantua, but still that means that it's actually 4 times more massive than our sun. So this black hole, because it's located at the center of this cluster of stars, then because it is so massive and it is so what is a black hole actually? A black hole is a region in space that it has a lot of mass, it is very dense, and it is in a small region, which means that basically even light cannot escape. So when you want to put this in the middle of a cluster, it actually dominates the whole cluster in terms of the dynamics, but it also makes it very crowded, very hot, very violent region, which makes basically the process of how do you form stars in this region, it's not easy. So we know that there are young stars, and that's what I want to study, is by looking at different images in the infrared, taken with the James Webb Space Telescope, in order to see if these young stars are actually there or not, and how are they. And because we know they are usually forming from clouds that are cold and massive, but then how can they be there? So that's what I want to do. And this is actually related to the proposal that I just submitted also, which is to study young stars in other massive clusters close to the supermassive black hole, which all to answer basically the question, how does it like to feel? What does it feel actually to live close to a black hole? Thank you.
A really fascinating journey to the stars and beyond to the supermassive black holes.
Thanks.
Wow. So you have been running out of time here. I think that's typical. In your proposal today, you have been applying for telescope time. Is this correct?
Yes. Yeah.
So all the astrophysicists around the globe, they want to use this fancy space telescope, and you have to share the time. How much time do you usually get? Is it minutes? Is it days? So
it's actually hours. So what I just submitted is about 33 hours, but it's basically usually the telescope, because it has to move, right, and point to where you want to look at, and it basically puts the settings for the instrument you want to use, and so on. So usually the actual time that it is actually looking at your target is almost 40% of the 33 hours. So, but still you have to apply for the whole thing, because you are occupying the telescope times for this time, for this period of hours. Yeah.
So during this period, you can use it exclusively, so you can decide where to point, where to focus.
Yeah, well, first I have to convince the committee that is deciding on the telescope time. So basically, you usually have an idea, you write it down, you try to make all the arguments why I need to use this very fancy, expensive telescope, and if I want to use it, how can I get actually the best science out of it? So if you write this, and hopefully it gets accepted, the one I wrote today, then basically, yeah, you can point it according to what you wrote in the proposal. So, yeah.
And you know already where to find these supermassive black holes and the young stars. You know where they should be, at least?
Yes, I mean, I can show you where.
Yes, yeah, please, show me.
Wait. So actually, the ones that I will get data, I already got some data on it, is, wait, this is flipped.
Oh, okay, sorry. But is there upside down actually, in space?
Yeah,
no.
I mean, there is north and east, so this is north, actually. It's diagonal
sometimes
here.
It's interesting to flip also orientation also on a global, but yeah.
Yeah, it's basically you have to imagine you're lying on Earth, looking to the sky. Your head is north, your feet are south.
My head is always north,
So north and east, and the position of the black hole is here at the very center, and I am interested in stars that are here. So that is... in basically astronomical standards, it's very close. I mean, it's a few light years away, but it's very close to the black hole. Yes.
Do those stars have names?
Not yet. I mean, they just have numbers now because we are not sure if they are really stars or are they just dusty blobs that happen to be there. But I mean, other stars, they do have names, yes.
But is it possible, or is it the big dream of astrophysicists to name one of those stars one day?
Yeah. I mean, I did name 2 stars.
You did already?
Not these, but other stars that we found very close to the black hole that they are orbiting. We didn't know if we know them before or not, so we called them...
How did you call them?
So the stars very close to the black hole, they are called the S stars. So there are S1, S2, S2, and we named them NS1 and S2.
S1 and S2. Oh, how charming!
So basically, like a new star 1, new star 2, or Nadeen Sabha 1, Nadeen Sabha 2. So it's like so it was.
So the next one is Nadeen 1 or Nadeen 2, maybe Nadeen 2.0.
We'll see. Yeah. I mean, they are 44 that we are looking at. So let's see.
Okay, maybe if you need inspiration, just give names to Nadeen, because S1, S2 is a little bit boring. Maybe next time you find even more creativeness. Nadeen Sabha, great story. Thanks a lot.
Thanks a lot. Thank you.